Good morning students, welcome to our lecture of data structures and algorithms. In our today's class we will study about queues and linked list. It is the topic of second unit. In our previous unit we studied about stacks, and in introduction lecture of data structures we studied that data structures are of two types, linear and non-linear data structures. So discussing about queue and linked list. Queue and linked list are types of linear data structures, that means data that is stored in a proper sequence or a proper format. That proper sequence can be either increasing form or in decreasing form. So queue is a linear data structure. In queue, whenever we are adding any element, that element is added at one end, and that the name of that one end is rear of the queue, and the deletion of already existing element takes place at the other end, and that other end is known as the front of the queue. So queue data structure has two ends. From one end we add elements, and from the other end already existing elements are removed. Comparing queue to stack data structure contained only one end, and that end was known as the top of the stack. That end was responsible for adding and deleting the elements from the same end. But in queue we are having two ends. From one end we are adding the elements, and that end is known as the rear of the queue, and the other end from where we are deleting elements is known as the front of the queue. The principle of queue is first in, first out. That means the element that is added, the element that is added to the queue, the first element that is added to the queue will be the first element to be removed from the queue. Understanding this with an example, the example of queue can be ticket window or bus stop. That means whenever we want to watch a movie, we just go to the ticket window to buy tickets. At that ticket window, a queue of persons is available. The person comes, takes the ticket and leaves the queue. So the first person that came to the queue will be the first person to leave that queue. So this is the example of principle of queue. That means the first person who entered the queue will be the first person who will leave the queue. So first in, first out is the principle of queue. Discussing about queue operations are insertion operation and deletion operation. Mainly these two operations are performed on queue data structure. In insertion operation we will see that whenever any element, any new element is added to the queue, how positions of rear and front ends are changing. And in deletion operation we will discuss the already present element of queue when deleted, how position of rear and front end is being affected. So let's start with the insertion operation. In insertion operation, insertion of an element always takes place at the end, and that end is known as the rear of the queue. So the end from which we are inserting any new element to the queue, that end is known as the rear of queue. Let's understand this with an example. Suppose that we are having an empty queue. In that empty queue we can store 6 elements. So initially the value of rear and front ends will be -1. As in case of stack, the initial value of empty stack was also -1. So the initial value of an empty queue will always be -1. The value of rear and front both will be at value -1. So when we are inserting first element, that is A. When we want to insert the first element A to the empty queue, when we will insert this first element A to our empty queue, the value of rear and front end will increase by 1. So the value of now rear end will become 0 and front end will also become 0. When we are inserting second element B to the queue, when we want to insert the new element B, the new element B will be inserted after A, like a queue that is present at a ticket window. So when we are inserting second element B, the second element B will be inserted after the first element A. So B will become the second element that will be inserted in the queue. Now after inserting B, the value of rear end will again increment by 1. Whenever we are inserting any new element to the queue, the value of rear end will always increment by 1. So after inserting B to the queue, the value of rear end will again increment by 1. Then after inserting the third element C to the queue, the value of rear end will again increment by 1 and the value will become 2. Now the thing that we should note here is that whenever we are inserting any new element to the queue, the value of rear end is always increasing by 1 and the value of front end is not changing at all. So in insertion operation, the value of rear end will always increment by 1 whenever we are inserting any new element. In deletion operation, the deletion of already existing element always takes place from the beginning, that is, that end from where the already existing element will be deleted is known as the front of queue. Initially we are having a queue in which 3 elements are present, A, B and C. The value of rear end is 2 and front end is 0. Now the element that is to be deleted from this queue will be the first element, because A was the first element that was inserted in the queue. So A will be the first element that will be removed from the queue, because first in first out is the principle of queue. So element inserted first will be the element that will be first removed from the queue. So if we want to remove the element A from this queue, A element is present at front position. Now whenever we are deleting any element from the queue, the value of front end will always increment by 1. In insertion operation, the value of rear end was incrementing by 1, but in deletion operation the value of front end will always increment by 1. So when we deleted A from the queue, the value of rear end does not change, but the value of front end incremented by 1, because in first step value of front end was 0. After deleting the first element A, the value of front end incremented by 1 and became the value 1. Now in second step, when we are deleting the next element B, after deleting the next element B, the value of rear end remained same, but the value of front end again incremented by 1. Similarly, we can delete the already existing elements. The points that we should always keep in mind are: in insertion operation, the value of front end will never change, but the value of rear end will always increment by 1. But in deletion operation, the value of rear end will remain unchanged, but the value of front end will always increment by 1. So this was the queue operations. We discussed about queue, that queue is a linear data structure. Then we discussed about both the ends from where new element is inserting and the already existing elements are deleted. Then we discussed about the example of queue data structure, the principle of queue data structure, and then we studied about insertion operation with an example and deletion operation. From both these operations we concluded that whenever new element is added to the queue, the value of front end remain unchanged but the value of rear end always incremented by 1 whenever a new element was added. But in deletion operation the value of rear end remain unchanged but the value of front end always incremented by 1 whenever an already existing element was inserted. So this was all about queue and queue operations. Thank you very much.